Hello everyone, this is my presentation for linked lists for ComSci 123. So today we're going to discuss linked lists, arrays, comparison of linked lists with arrays, singly linked lists, doubly linked lists, circular linked lists, unrolled linked lists, and skip lists. Alright, so first, what is a linked list? So it is a data structure that is a series of connected nodes. So each node stores the data and the address of the next node. So in our visual representation right here, this whole blue box rectangle is a node and it contains the data and the address for the next node. So its properties are its elements are connected by pointers. So it can grow or shrink in size during execution of the program. It can be as long as we want, and it does not waste memory space because memory allocation is done during the execution of the program. It grows or shrinks. So what can we do with a linked list? So we can insert, which means it inserts an element into the list. We delete, which removes and returns the specified position element from the list. You can do delete list, which removes all the elements of the list. And we can do count, which returns the number of elements in the list. So we have arrays, which is a collection of same data type items. So by saying same data type items, all the items and element must have the same data type. So other data types are byte, short, integer or int, double, float, char or char, strings, array, and classes. So let's say you have a car here in one of your elements, so everything in your array must also be a car. Or let's say you have an integer, so if you have an integer right here, so everything here must all be an integer. Alright, so in an array, each item is what you call an element, and each location is a numerical index, which is used to identify the element. So you can see it right here. The location is right here, the 0. This is what you call index. So at index 0, the element is 11. So index 1, the element is 9. This is the index. This is what you use to find the location of the element. So what can we do? We traverse, which means we travel inside the array. We can do insertion, which adds an element at the given index. We can also do deletion, which deletes an element at the given index. And we can do search, searches an element using the given index or by the value. You can either search an element by finding the index or by the value. So we can also update, which updates an element at the given index. So if you update, let's say you wanted at index 4, you wanted to change the 1 to 5. So first you find the index, then you change the element to 5. That's how we do it. So it's the same with search. So we also have what we call the dynamic arrays. So a dynamic arrays is also known as a growable array, resizable array, dynamic table, or array list. So what's special in dynamic arrays is that since a normal array, its size cannot be changed. So in dynamic arrays, you can change its size. So it expands when an array is full, and it can also shrink when the items are less than half. So in our representation right here, we have what we call a myArray. We have a current array with the name of myArray. So when it expands, it creates a new array with the size double of the old array. Then it copies the elements from the old array to the new expanded array. So what you have right here after resizing. when you shrink, you can do the reverse. So let's say you have an old array here, current array, with only 5 elements. So it's half of the array capacity. So you can shrink it. You can create a new array with just 5 elements. You can store 5 elements inside. So then you copy all the elements from the old array to the new array. Alright. So in comparison to an array with a linked list, so an array has a fixed number of data items, while the linked list has a changing number of data items. An array has a fixed size, while the linked list has a changing size, because the size is already allocated during before the program is run. While the linked list, you can change it. It is changing while the program is running. So storage allocation for arrays, it is during compile time, while the linked list is during running time. So in the order of elements for an array, it is stored consecutively, while in linked list, it is stored randomly, because in the array, you store the elements by index, diba? It is counted from 0 to until the capacity of the array, while in linked list, you can insert elements at the front, at the back, or at the middle, so it's random. In accessing the element in array, it is direct or random, because you just find the index and then you find the element, or you find the element and you find the index. But in linked lists, you do it sequentially, because you have to traverse each element to find whatever element you want. So it is insertion and deletion of elements. In an array, it is slow because of shifting. Because when you delete an element, all the elements in your array must move forward to fill in the missing element. So in linked list, it is fast because you can either delete at the front, at the back, or at the middle. Or you can either insert at the back, or at the front, or at the middle. So in searching in array, you can do a binary search and a linear search, while in linked list, you can do a linear search. While memory required is less, while linked list is more. Memory utilization in array is ineffective, while linked list is efficient. So we have what we call a singly linked list. So it is a concrete data structure consisting of a sequence of nodes. So this is like the normal linked list, because each node contains the data and the link to the next node. So what we do is we keep track of the head node and the tail node. Then insert and delete a new SLL node at the front, and also insert a new node at the back. So it is not recommended to delete an element at the back, because when you delete, we update the tail node and the head node. So if it was at the front, if you delete at the front, you can update the head node to the next node. But if you delete at the back, it will take O of n time to update the tail node, because you cannot go back. You can only go one direction. So if you want to delete at the back, you have to travel the whole list again to find what is next of the old tail node, so you can update the tail node. So we also have what we call the doubly linked list. So a doubly linked list node contains a node which contains its data and the address to the previous node and the next node. So what you can do here in the doubly linked list, you can already go back, unlike a singly linked list, you can only go forward. So a DLL, a doubly linked list, has special nodes called the head guard and tail guard, which we call sentinels. So these are dummy nodes that don't store data. So when a doubly linked list is created, it already comes with a head guard and a tail guard, even if you don't have any nodes yet, if you don't have any elements yet. We also have what we call the circular linked list. So what it does here is that the last element is linked to the first element. It can be used when implementing stacks and queues, which we'll learn later. So in a circular linked list, so let's say in a circular linked list, it when you say circular, when it is circular, so it uses any available space that you have. So if you have an available space at the back, after deleting or inserting an element, the any available list at the back will be used. It will just wrap around, just like in our representation right here, just goes back to the front. So we have unrolled list. So this one here is that there are multiple elements in each node. So just like our representation right here, this whole array or box here stores multiple elements in one node, unlike the usual single linked list or double linked list. It only contains one data type. So it follows a circular linked list in each node. So in each node follows a circular linked list so that you can utilize all these available spaces in each node. So in skip lists, skip lists are also a list which starts with a basic ordered linked list right here. Every node is connected, and a new layer is added on top of the bottom list. So the new layer is the one right here, and every layer on top. So the first node is often always kept as a header for the new layer. So as you can see here, now the first node is always there, and it allows the process of item lookup in an efficient manner because you skip items and you don't have to travel every link to find whatever element you are finding. So it skips an item, so it's more look like an express lane. You just skip the elements, skip other nodes to find what you want to find. It's faster. So application of linked lists. Application of linked lists in real life is like, for example, image viewer, because the previous and next images are linked, hence it can be accessed by the next and previous button. Just like in your gallery, when you swipe to the right, then you will see the next picture, or you swipe to the left, you see the previous picture. So it's the same with the previous and next page. The web browser, you can access a previous and next URL. Search in the web browser by pressing the back, since they are linked. And the music player, the songs in music player are linked to the previous and next songs. You can play songs either from the starting or ending of the list. And that's the same. You swipe right, you can see the next song, or if you swipe left, you can also see the previous song. Unless if you are doing shuffle, if you shuffle all the music in your music player, then it's also the same. Every music is connected, every track is connected. So thank you very much for listening, and I hope you understood the basic concepts of linked lists and arrays. So thank you very much and have a good day.